Today is a really a special Nature Journal workshop because we have a special guest, not Gray the Penguin, but we have there's an incredible team of ecologists, conservationists, biologists um, at Point Blue Conservation Science. Um, and we're going to be meeting with them and their penguin expert team to learn more about this world. First, I want to say something about Point Blue. And then I'm going to be bringing on the chair of the board of Point Blue Conservation Scientist, Point Blue Conservation Science, um, to to help frame what we're going to be doing and introduce our speaker. But it is critical these days to understand our world through the lens of science. It turns out that when we just kind of gaze around with our sort of normal human brains, we see anecdotes and we remember anecdotes, but our brains are not as good at collecting data in a way that is systematic and actually tells us meaningful things about the place and the functioning of the planet. So statistics is something that we are blind to. And to get really good science is hard work. It's hard work when you are not in sub-zero conditions. But even more so when you're working on the continent of Antarctica. But this is where Point Blue Conservation Science comes in, because this crew of people um, provides the world with incredible, useful, actionable data for conservation decision making. And this is exactly what we need right now. And so I'm going to bring on Ann Chadwick, who's a avid nature journaler, as well as the chair of the board of Point Blue Conservation Science. And it's a delight to have you with us today. Um, and maybe just tell us a little bit from your perspective about why you chose, of all the things that you could be like giving your heart and energy to, tell us a little bit about Point Blue and perhaps to introduce us to our speaker for today.
Thank you so much, Jack. Yeah, I've been involved with Point Blue for many years, and I came to it through the Truckee Donner Land Trust, where I was working on conserving. Now I think we're up to 40,000 acres in the Sierra, and we were working on restoring mountain meadows, one of our favorite topics. And we could do the stewardship and build trails and invite people in, but we didn't really have the science to know what was going to be best ecologically and what would be sustainable. So that's where Point Blue came in. As you said, not just anecdotes, but the data, the research. And so I got to see how important that is in the work that we all do to try to help make the planet healthier and better. And so once I went off the board of that organization, I came onto this one, and now I'm chair of the board. So enjoying that a lot. And I always enjoy being with you in the Nature Journal workshop and seeing all of our friends out there. So I am delighted to bring you yet another brilliant scientist from Point Blue doing important evidence-based work to protect and preserve our environment. And I'm also really excited. I've been packing because I'm going to Antarctica at the end of the month.
Jealous.
And you know what? It might be cold. So I've got my neck warmer here,
The
and
official Point Blue neck gaiter.
yeah, that's my new swag. And if I'm lucky, I might get to see some penguins, even
Uh,
a chick.
it could happen.
I'm hoping. Hi, chick. So, but more seriously, I'm coming to you from Sebastopol, California, in Sonoma County, where we're headquartered in Petaluma and Sonoma, north of San Francisco. And I'd like to acknowledge that I'm on the sacred, ancestral, unceded homelands of the Coast Miwok and Southern Pomo people, known today as the Federated Indians of Great and Rancheria, which is a federally recognized tribe and a sovereign nation. The purpose of this acknowledgement is not meant to just check a box, but to commit to actions, correcting the stories and practices that erase Indigenous peoples' history and culture, and to consider our own accountability to those who came before us, those who are here now, and those yet to come. So I'll tell you a little bit more about Point Blue, and then I'll introduce Dennis. But we are a community of over 160 scientists and a whole lot of nature nerds like you and me out there, and all of you. And we do many things. We assess, guide, and improve climate-smart conservation. We maximize the use of long-term ecological data for problem solving worldwide. We advance the application of conservation science to protect nature's benefits for wildlife and people. And we train new generations of conservation leaders. Now, a couple of those leaders who have basically grown up with us at Point Blue are here with us today. The first is our wonderful communications manager, Lishka Arata, who is behind the scenes today, answering your questions and providing important resources in the chat. Many thanks to you, Lishka, for all the work that you're doing in connecting art and science to communicate our mission. And our special guest today is Dennis Jongsomjit. He is a geospatial ecologist at Point Blue, who has focused his efforts on modeling, mapping, and investigating landscape and climate change factors affecting the distribution of wildlife populations. He's worked on projects anticipating distributions and abundance of vegetation and birds throughout the western US and northern Mexico. He's modeling efforts of looking at sea level rise effects on tidal marsh habitat throughout the San Francisco Bay, super important work. And as you'll see today, he's been modeling the distributions of species in Antarctica and the Southern Ocean, including penguins. And Point Blue has been conducting research in Antarctica for nearly 30 years, and Dennis has been there 5 times. So we're really pleased that earlier this week, his article came out in Ecology magazine. It's a huge deal. And it's about the movement of Adélie penguins on sea ice. You see, despite all this work that we've done over all those years, there's still so much more to learn. For example, recent advances in the miniaturization of electronic tags allowed Point Blue to put tags on 87 individual penguins. And we monitored 46 trips spanning 3 years, 146 trips over 3 years, and used this data. Dennis, it was part of his master's work, and he led the investigation to understand in greater detail if and how Adélie penguins interact with sea ice during their long-distance winter migration. So the results revealed that, yes, indeed, the penguins use the movement of sea ice during their northward migrations, which allows them to travel farther and potentially use less energy when they receive the help from the sea ice. But it's complicated, and Dennis can tell you why. And Jack, are you ready for a pun?
Oh, bring it.
I'm bringing the puns. Have to do it. So guess what the title of Dennis's paper is? Going with the flow.
Oh,
See what he did there?
do it on purpose, going with the flow.
Yeah.
Oh,
Sea
that's
ice movement affects distance and destination during Adélie penguin winter movements. That's his title. So, and one more thought, do your sketch noting. I'm so excited that it's sketch noting day. I've been practicing my penguins,
oh.
but get
And,
your,
and pretty soon you're going to be trying to do that, and your paint will be freezing as you try to put it on the paper.
yeah.
So the
But, you know,
have you looked into putting some alcohol or other distillates into
yeah, I was reading
brush?
about that. Like, and I'm sure that
Without freezing.
on the ship, where I'm not going to our research base, I'm going to be on a ship, and I'm sure they'll just give me a couple of drops of vodka or something with that. Is that what we're talking about?
Yeah.
Okay. Um, so yeah, everybody start sketchnoting. Dennis is going to have some great pictures, some video, lots of great information. So think about your words, pictures, and numbers, and we'll get into more detail with Jack and the drawing afterward. But I'm ready to turn it over to Dennis, or back to you, Jack.
Excellent. And again, I'm just so delighted to have Point Blue here with us. I actually have a long history with this. My dad was a lifetime member of Point Reyes Bird Observatory, which then evolved into Point Blue Conservation Science. So our family has a long connection with the great work that you're doing. So with that, let's bring on Dennis. I'm going to add you to the spotlight here. It is wonderful to have you with us today, and thank you so much for that introduction. We've kind of gotten a little peek under the hood of your research, and congratulations on being you were published in Nature.
In ecology.
In ecology, excellent. That's fantastic. So what we're going to do is let's just talk a bit, then we'll let you take away the show. I was wondering if you could just sort of first just tell us about how you got connected with how did you get involved in this work in conservation?
In general, in conservation, well, I talk about that a little bit in my presentation.
Oh,
but
okay. Then forget that. Let's start the show. I'm going to make my screen and Anne's get small. We're going to turn the whole screen over to you, and we're really appreciative of you being here with us. I'm going to remove my spotlight, and then here we go. And you
maybe I can share my screen.
Oh, I think
here. Yeah, I can do that.
Yes.
Sure, my sound is on. Okay. You guys can see my slide?
Yes.
Awesome. Yes, thank you so much, Anne and Lishka and Ivea and John for the introduction. And good morning to everyone else that's here. It's really exciting. Thank you for being here. And really thank you for that introduction. My name is Dennis Jongsomjit, and I work here at Point Blue Conservation Science. I'm really excited to be here. I've been meaning to join one of these workshops for a while now, and here I am presenting at one, so that I'm really stoked and excited about that. And today I'm going to be talking about Antarctica and our work in Antarctica and within the Ross Sea as well, and Adelie penguins as well. So first of all, just wanted to say a quick thank you to all my coworkers, colleagues, and friends who I've worked with over the past few years. All the work that I'm talking about today was really led by many of them, and so many other people as well that I can't list them all here. And I'm really thankful for being part of this team and having the opportunity to go down to Antarctica. So today's talk is really about, I kind of break it down into 4 parts, and it's really about wanting to connect all of you to different parts of Antarctica. Well, first of all, I want to connect you to me a little bit, and as Jack was asking, provide a little background about myself, where I come from, how I connected to this work. Secondly, I want to connect you to Antarctica as a whole, and then also to this area that we call the Ross Sea, where Point Blue does most of our work. Third, I want to connect you a little bit to the science that we do and the conservation work that Point Blue is doing within the Ross Sea. And then finally, probably what most of you are here for is connect you to the Adelie penguins and penguins in a little bit more detail. The Adelie penguins that you see in this photo here, these are our primary study species. Okay, so part 1, my connection. Just a quick orientation of where I come from. I grew up in this apartment building here, almost literally in the middle of Los Angeles, one of the centers of like urban sprawl. And for 18 years, this was my neighborhood growing up, just LA. You can see downtown LA out in the distance in the background. And really, this LA basin was kind of my entire world for a long time. My family and I didn't have many opportunities to leave La La Land. And from a young age, I kind of felt out of place here. So I really spent a lot of time uh, escaping by watching wildlife programs on TV and sort of daydreaming about one day, being one of those people that's out like chasing lions and things like that. And being in the middle of LA, this was sort of a strange desire compared to all of my friends. A lot of ecologists that I meet today or work with today, they grew up spending a lot of time in the outdoors and camping, but I was really only able to kind of daydream about it. And so after high school, I quickly left this urban environment, and I went to UC Davis to study wildlife conservation biology. And after graduating, I did my first internship, but here at this yellow X with what was then PRBO, or now it's now Point Blue Conservation Science. And this was out at the Point Reyes National Seashore, and this was as isolated as I had ever been and felt. And I immediately sort of felt this understanding that, this is where I needed to be. So for 4 years here, I studied song sparrows and wren tits and other songbirds out in the coastal scrub. But even in this beautiful wild place out at Point Reyes, I still felt this human pressure. San Francisco's nearby, sprawl growing, and I had this continually building desire to, go even further away. And one of the furthest places that I could think of on Earth was, this place that we call Antarctica. And I got this amazing opportunity to head out there, and I decided that I wanted to go back to school and study this unique ecosystem a little more. Now, when we all think about Antarctica, we often see it as this sort of cold, distant place in the middle of nowhere. This view that you see now is sort of how we often see the continent, out all alone, with nothing around it. But in fact, Antarctica is, I think, a lot more connected to you and to the rest of the world than we usually think of it is. For example, there is this ocean current that encircles the continent. It's called the Antarctic Circumpolar Current. And it's the only current on the planet that connects all the major ocean basins of the world. And in doing this, this current plays a key role in the global ocean circulation patterns, which in turn help to regulate things like the Earth's temperature, the carbon in the atmosphere, and our climate. So really, when you think about this, when you account for this global connection, this is another way of viewing that. Here we see both the surface and deep ocean water currents made possible through the circumpolar current. And well, I like to think about it sort of as kind of the beating heart of this planet. If you're not convinced yet that you're connected to Antarctica, it also helps to know that it holds around 60% of Earth's total fresh water as ice, and 90% of all ice on Earth. And if this ice were to melt, it would be the equivalent of about 60 to 70 meters rise in sea levels. So, it's good to know. So let's zoom in a little bit more and get connected to the Ross Sea. Within the Ross Sea is where Point Blue focuses a lot of our work in Antarctica. This is a pretty special place. It's one of the most productive oceans on the planet, and it's also one of the least human impacted ecosystems on the planet. It's home to a really diverse set of species, including, to name a few, Weddell seals, South polar skuas, leopard seals. Here, this one kind of sadly attacking a penguin. Emperor penguins, also snow petrels, and also, of course, our steady species, the Adélie penguin. But even though Antarctica, is relatively isolated, when I got there, I began to learn that there are actually, existing and growing human pressures within the Ross Sea and Antarctica as a whole. This includes things like changes in climate and the related changes to sea ice. And there's also been a lot of fishing pressures and an ongoing interest in resource extraction around the continent. As an example, with fishing, there's a big toothfish fishery within this area. Now, some of you might wonder what is a toothfish exactly, and why do people fish for it? But it's more commonly sold and known as Chilean sea bass. And I think many of you might have probably heard of Chilean sea bass or even eaten one of those. So this is another way that you might be connected to Antarctica. The seafood choices that we all make can have an impact in this region. Sort of like the food webs that many of us learn about in school, all the species here are connected in some way. Toothfish are connected to krill, krill are connected and to killer whales as well. Krill are connected to penguins. Penguins are connected to leopard seals, etc. So in this context, really understanding what resources wildlife need and how they use them is becoming more and more important. So in a nutshell, as we sort of zoom over here over our study site, studying this place is kind of a unique opportunity to study a relatively intact food web and assess how climate change is going to impact that relatively intact food web, with sort of a limited human disturbance in the area. And this stewardship and using this knowledge to inform and improve protections are really what drives me and a lot of us at Point Blue in our work. This is, what you see here, the final shot is sort of looking out to sea from Ross Island, and you can see the sea ice beginning to melt and break up a bit. So the ocean does freeze down there, and then it changes seasonally. Okay, so part 3 of 4 now. I want to sort of begin to paint a broad picture of why this place is special and what Point Blue is doing here exactly. So as Anne mentioned, we've been studying Adelie penguins and the breeding colonies out on Ross Island since 1996. That's almost 30 years. And the main focus of the work here has been to really try to understand what drives penguin success stories and failures. How do the penguins cope with changes in their environment? How are those mounting pressures that I talked about impacting penguin populations? How are penguins connected to krill and whales and changes in sea ice and climate? And the way we do this is at a pretty fine scale by closely following and tracking individual penguins. Long-term monitoring is really at the core of what Point Blue has done for a long time. And it's no different here in Antarctica. We place bands on penguins with unique numbers on them, and this allows us to follow them throughout, almost their entire lives. And in this way, they tell us how they're doing. And with respect to protections and conservation, so there's a general agreement, around the world that Antarctica is a special place and deserves to be treated that way. Back in 1959, there was a treaty that was signed, which sort of laid the foundation to facilitate scientific research and cooperation and environmental protections within the continent. But the marine environment around Antarctica is still pretty vulnerable. And recently, over the last decade, there's been a real push to establish more formal protections around the continent. Just to give you a highlight of some of the work that we've done down there and the results, back in 2012, Point Blue was involved in trying to establish a marine protected area around the Ross Sea region. And using our data and data from numerous partners, we developed models that helped highlight and rank areas within the Ross Sea. So here on the left, there's two maps. On the left, you see a ranking of species richness with darker colors indicating more species. And on the right, you see an overall conservation ranking that we developed with the data that we got. And we published these data and these maps in Biological Conservation, another journal. And subsequently, we used them along with several partners as part of the process of developing and recommending protective boundaries for the Ross Sea. And these protective boundaries are what you see here. This gray, kind of darker gray area is the Ross Sea Marine Protected Area. And this was finally established after years of work by a lot of people in 2016. It's one of the world's largest marine protected areas, encompassing around 400,000 square miles. And just to orient you a little bit, this arrow down here is Ross Island. It's way down at the bottom of the Ross Sea. And the Adélie penguins that we study are on Ross Island. So, you can say, well, this is protected. That's great. Like, work done, right? But actually, it's more complicated. Some parts of this MPA are designated as special research zones where there's still fishing allowed to continue. Also, some areas that we highlighted as having high biodiversity were left unprotected and remain open to fishing. This is part of the negotiation process that happened when establishing these boundaries. And then also finally, this is really the first MPA to have a time limit set on it. So it's set to expire. It was set to expire in 35 years and be reevaluated at that point. So in other words, its protections come with some controversy and some caveats. But from sort of an optimistic point of view, this means that there's room for improvement. And briefly, to talk about my work a little bit, which Anne introduced, this was really focused more on the winter migration patterns of Adélie penguins. Although we study them a lot on the breeding grounds on the Ross Island, we know relatively little bit about their winter lives. And this has been a more recent focus for this project as a whole, is what are the penguins doing when they leave Ross Island and travel north in the winter? And my overarching question for my master's thesis was, does the movement of sea ice help Adélie penguins during their migratory movements? So Point Blue has been using a lot of technology recently to answer ecological questions. And for my work, I took advantage of data that came from these miniature tags that we placed on penguins to follow them throughout the course of the year. And here I sort of give a breakdown of the kind of information that these tags collect. We call them GDR tags, and they're really amazing, remarkable. They're really small, but for a whole year, they can record penguin location, depth, and the temperature around them. So these things have been getting better and better every year, and we're taking advantage of that. And so I use this information. I followed penguins for a year. Here on this map, each of these dots represent an individual penguin in maybe around June or July when they're up north. And you can see, they leave the protected areas of the Ross Sea MPA. And I use this data together with satellite data, which looks at sea ice and the movement of sea ice to see how they're using that sea ice to help them move. And like Anne mentioned, we did find that basically the more that their movement coincides with the movement of sea ice, the further they're able to move. So, they're really dependent on this ice to help them move north. But this sea ice is, it changes from year to year. And so this is just kind of a first step in understanding what might those changes to the sea ice, how might that impact the penguins during their winter movements? And it's really a part of expanding our knowledge about them to help us understand what it is that they need. Okay, so just let's move on to the final section here and begin to connect you to Adelie penguins. So Adelies, they have breeding populations throughout the entire continent of Antarctica, and it's the most widely distributed Antarctic penguin. And when I say breeding, I mean that they come onto land once a year, and they spend about 3 or 4 months setting up a nest, mating, laying 2 eggs, and trying to raise 1 or 2 chicks. The rest of their lives, the 8 or 9 months of the year, they're out at sea, and they're out in the ocean, on the sea ice, living out their lives. They are what we call sea ice obligate, meaning that they depend on sea ice for a lot of things to help them survive. Our Adelie penguins can spend, when they first leave the colony, they can spend years out at sea. And when we see them on land, it's really just a really small fraction of their lives, maybe 10% of their lives on land. Because they're so broadly distributed, because of their diet and their close connection to sea ice, the Adelie is considered an important indicator species, meaning that they can provide a lot of information about the health of the ecosystem that they're a part of. The primary diet of the penguins are both krill and silverfish. Seen here in this image that sort of what I imagined a penguin would dream about, surrounded by fish and krill. So above the penguin here are silverfish, and below are krill. And our birds on Ross Island consume mostly krill when they're breeding, but this changes, seasonally and even within a season. And this is something else, their diet is something else we keep track of that helps us understand how their environment is changing and how penguin needs are changing. I often get asked if penguins are birds, and this is understandable because there's a really weird creature. They're birds, but they don't fly. There's over 10,000 species of birds on the planet, and of those 10,000, only about 60 don't fly. And a third of those that don't fly are penguins. And in a new book by David Adelie and Rory Wilson, they really dive in on how these birds became fish birds. And they start the book with a poem, which I think is really spot on and interesting. If you get a chance to check out this book, I've read the first few parts of it, and it's really great. Okay, so even though continuing on with their ability their inability to fly, even though they can't fly in the air, penguins are actually really amazing flyers underwater. There's a short video. So yeah, that was just a little glimpse of a pool that formed on the sea ice that I managed to just kind of dip my GoPro in and capture that scene. But at Point Blue, we're doing things like putting small miniature cameras on penguins now to see what it is that they're foraging on, and where they're diving. And when Adelie penguins are out at sea, they have been actually known to dive up to 180 meters. And I wanted to put this in some perspective, so I sketched this chart, which sort of shows different depth markers for reference. Humans at 20 to 60 meters, the extra pressure becomes dangerous for a lot of different reasons. A soccer field is 100 meters. They go beyond that. 10 city school buses all lined up in a row. They can still go beyond that. 180 meters is about a 55-story building. So it's crazy to think about that this little penguin can do that. And I also wanted to highlight how, these penguins are really individuals with different personalities and different looks. One thing we like to look at and ponder while in the colony is their armpit markings. So here I wrote, they come in different sizes. Why is that? Well, in birds, coloration can sometimes show how healthy an individual is. So one idea is that these armpit markings could signal to potential mates how great of a parent they can be. And that's just one idea, maybe you can come up with other ideas. So to finish up here, I just wanted to sort of give you a quick introduction. I thought this would be cool to, as part of a sketching workshop, to look at the different expressions and body postures that penguins can show. We might normally think of them as sort of this standard, simple black and white bird, that waddles around, but in fact, they're very expressive and they can tell you a lot about how they're feeling with their eyes and with their body posture. So let's give you a little quiz, and I'm going to show some images and you can sort of think about what it is that penguin is signaling to you or what it's showing. There's a couple of adults and a really fat chick. The one on the right, the big fat gray chick, is what we sort of call pineapple plus size. We use the fruit scale to size them when we're out in the field. And, these birds are kind of looking sleepy, nothing too surprising. Here's a few more, sleepy, resting penguins. Their eyes are kind of closed. The penguin on the right that you see here, it's got a silver band on its flipper. And those are the bands with unique numbers that we place on them so we can identify them as individuals from year to year. Okay, what about this penguin? They tell you a lot with their eyes, and this one is sort of got this kind of wide-eyed look. And, this can be a sort of sign of stress a little bit. So here, it did not like me to be this close, so I backed away from its nest. Just pointing out this little yellow tag here that we put on nests to help us identify them out in the field. Let's see, a couple more. These penguins are perhaps stressed as well. You see their kind of wide open eyes. The one on the left has this sort of crest on its head, and they can raise that a little bit as a sign of stress, right there. And this other penguin here kind of has like its flippers off its body, and it's kind of leaning forward. And that's kind of a sign of aggression as well, and stress. And this group of chicks here they're huddled up into what we call a creche, and they do that when they reach a certain age and join together for protection. So penguins are curious for sure. They'll come up to you themselves if you're just standing there, and they'll like look at you, and they have this kind of wide-eyed open look, which I interpret as curiosity a little bit. And then finally, these penguins here still have that wide-eyed look, but they're actually singing to each other. They're calling to each other when they come back to the nest to help identify each other as like, are you who I think you are? Yeah, okay. And they get this kind of wide-eyed look and they start swinging their bodies around. So wondering how you did on the quiz. Hopefully you did pretty well. And with that, I just want to say thanks for joining me today, and looking forward to getting sketching. So I'm going to let it go from here.
Oh, this is really, really fun. Thank you so much for sharing this, Dennis. I have been working on my sketch notes over on this side, and I learned a ton about about these little beasties. Let me see if I can find my. I'm gonna join you on the screen here. So something that I noticed is that you did those drawings, right?
Yeah.
So you're also an illustrator, and on top of being a biologist as well.
A little bit. I dabble a little bit, and I'm actually been inspired by some of your sketches that I follow you on Instagram. So yeah,
Oh,
been
see,
inspiring.
well, then we can mutually inspire each other. Um, this is really cool. When you are out there in the field, do you keep a journal, a notebook, that you include sketches in as well?
A little bit, yeah. We have notebooks that we collect data on, and so there is room to do some basic sketches, but mostly I'll do my sketches once I come back in from the field, and doing sketches out in the field is something that I need to practice more.
Yeah. Also, you get hypothermia. Your fingers, you have to
Yes.
sit still, and then you have to have your fingers out. What kind of air temperatures are you hitting on a balmy summer day?
On a balmy summer day would be about, freezing, 32. But there's on a nice day, there'll be no wind. So you can actually stand there and feel okay at 0 degrees because you have a lot of layers on.
Yeah, but then hard to get your fingers outside of the glove to manipulate a pencil. We're going to see how Anne Chadwick fares with this as she gets down there. Um, the so I have been uh, so so I was sketchnoting was things like I thought that this idea of the current going around here, then connecting all the oceans of the world, and then driving current patterns on the rest of the world is really, really interesting. I love this sort of metaphor of this kind of current pump heart that connects us down there. Um, uh, how long? What was your first year down there?
It was in 2014.
So you were there before the Marine Protected Area
Yes.
and got to see that change. What was the sort of the discussion on the ice? What was when you're out there with other biologists? What was the reaction? What was the experience when in 2016 the Ross Sea Marine Protected Area was established?
Yeah, well, I mean, I was part of that process in those discussions, and it was really interesting um, to sit in on these talks and listen to like the world's experts on Antarctica talk about what is important and why it's important, and also to talk about what they didn't know. So, which is really the majority of
Right.
things. Um, that was a very much a learning lesson to sit there and meet the world's leading toothfish experts and just hear about how much they did not know about that species yet. because it's such a difficult place to explore and study. But at the same time, they were doing what they could with the knowledge that they had, and
Right.
sort of developing like we still have to move forward. And so it was great to see that process, to see these boundaries getting developed, and then see it actually happen. Yeah, it was inspiring to me.
That, were you down on the continent when it was signed?
No, I don't think so. I think I was here back in the States when that happened.
This rafting around on the sea ice. So I noticed that some of the penguins, whoops, excuse me. So when you showed kind of the routes of the penguins took from there, some were going up to the left, or one was going up to the left. You showed another one kind of going out to the right. And the one that was going up to the left, is that against the current? So
Yes,
was
so
that not on sea ice, or is there a little eddy that brings sea ice up in that direction?
mhm. Yeah, so there is, within that Ross Sea, there is something that's called the Ross Gyre, and this is sort of a clockwise movement of ocean water, and that drags along the ice with it as well.
Got it.
Uh, and
Whereas the major, if this is the Ross Sea here, the major current is coming along like this, but then there's a little separate gyre kind of coming in here like this.
yep, that's the Ross Gyre. Yep.
Okay. And so they just get up on top of that and can, without expending a bunch of calories, get out to where um, the silverfish and the krill are.
Yeah.
Do water temperatures change the abundance of or maybe this is not one of these things, it's just like, we don't know. But to your, from data, from evidence that you have, do changing ocean temperatures change, how do they affect populations of krill and the silverfish?
Yeah, so like a lot of species, or for a lot of species out in Antarctica, sea ice is very important. It serves a lot of different purposes. For penguins and for krill and for silverfish, they can serve as sort of shelter. It can serve as this platform where they can rest in. For krill, it can serve as a nursery, sort of under ice parts of the sea ice can serve as a nursery for them. And so with warming temperatures and warming oceans, we're seeing changes in the sea ice, which is critical for a lot of different species. So I think what you're asking is like, is the warming going to affect them? And it is going to affect them somehow, but we don't know exactly how that's going to happen, how long it's going to, what the time is. And it's also very regional around Antarctica. Different parts are behaving in different ways. So for a long time, the Ross Sea was actually staying very cool, and the sea ice was increasing compared to other parts of Antarctica. But more recently, we're seeing historic warming temperatures, historic lows in sea ice extent and sea ice concentration within the Ross Sea. So it's
But
kind of
by
alarming.
recently, you mean within the last how many years?
Within the last, I think 2017 was one of a record low,
Yeah.
and this past year as well was another one. So yeah, very recent.
I know for the emperor penguins, there was, at least for some of the colonies, there was a crazy collapse of, there was something. Could you tell folks about what kind of happened with the sea ice? But this is my stuffed emperor chick
Yes.
here. The So this is the charismatic, you know, what was that? The March of the Penguins. beastie. What happened with, was it this year that we had that? Or sorry, last year we had what happened with do you have any more information on what happened with the emperor penguin chicks?
Yes. So um, that so we have emperor penguins near our breeding colony that we also monitor as well. So every year we go out and we count the chicks, the emperor penguin chicks, out on the sea ice. And for those that don't know, emperor penguins, they're even more sea ice dependent than Adelie penguins. They actually breed on the sea ice, and they have their eggs and their young on the sea ice. So they're truly a sea ice obligate, 100%. And this sort of collapse that's been in the news for different colonies, we also had a similar event happen on Ross Island a few years ago.
All right, so maybe first sort of tell folks about what happened, because I think there may be some listeners who are not aware.
Yeah. So I can tell you what happened at the colony that we study at. So I showed you that video of the sea ice sort of frozen.
That was
and
cool.
Yeah. And so on that sea ice, right off the colony, is where the emperors breed. And what happened one year was there was a big storm, a windstorm, and a lot of that ice that the chicks were sitting on got broken up and blown away. And this happened about 20 days before the chicks are sort of usually become more independent. And so we don't really know what happened, to all those chicks that the ice broke up and they just got blown away out into the ocean. But from the evidence, we saw a bunch of adults a few days later come in and sort of stand around on the remaining sea ice. And so our guess is that they were probably coming back looking for their chicks and they weren't there anymore. So
Yeah.
This was sort of a new thing for us, seeing this sort of big change that the emperors were perhaps not adapted to.
So, and I guess in other breeding colonies this year, there were a bunch of penguins on sea ice that melted, and we had a pretty catastrophic fail of emperor penguin reproduction this year. Is my understanding correct?
Yes. Yes.
Yeah.
I mean, in some ways, like, we're talking about thousands of years that these birds have been around, and they can probably adapt to some of this. They've probably experienced these kinds of things before in the past. But the worry is that it's going to happen more often and faster, a faster pace than they've ever seen before. So I think that's the concern, is that they're not used to this happening as often as we think it might be happening.
Yeah. Now, this last year was the hottest year we had on record on all these different parameters. It's interesting. Well, want to see some? This is really, really cool work, and thank you so much for sharing that. Should we take a look at some penguin drawing tricks?
For sure.
All right. Thank you for that. So, folks, at the end of this little workshop, we're going to do right now. We're going to show you some tricks on drawing penguins, and then what I wanted to do is we'll be back here for anyone to ask questions. Actually, having an Antarctic researcher who's been in the field, who you can talk to here. I want folks to come up with any questions which you'd like to ask, or thoughts or comments about your inspiration. Also, if people want to share any penguin-y sketches, please do. I'm now going to, let's see here, hold on a second. I'm going to minimize your screen, make mine big, and then we'll be back with you shortly. So let's see what we can do to I'm going to go to this. Oops, nope, not this. Bye, everybody. This. Actually, I want this to be a little bit bigger. All right. So I have a little notebook here. And let's go to new penguin page. We're going to be looking at drawing some penguins here, and on the side here, I've got some photographs. Some I found on the web, and some were provided to me by the good folks at Point Blue Conservation Science. So this is we're going to be focusing on the Adélie penguin, not to be confused with. Oh, hold on. It's not letting me from this screen change. One moment. All right, here we go. Not to be confused with the Adelie penguin, Grammy award-winning vocalist penguin. But we're looking at not the Adélie penguin, but the Adélie penguin. And let's just take a look at this shape. There's this really wonderful just kind of bottle shape that a penguin has. And we want to be able to catch that. Let's see if I can move on. Keynote. There we are. So I'm going to try to make this a little bit bigger so we can get bigger penguins. There we are. And so let's just to warm up. Everybody, just try a bunch of. Let's try a handful of just gesture sketches. I'm going to kind of get you going with a few of these, and then you'll sort of see what we're up to. And what it is for a gesture sketch to kind of warm yourself up with a penguin is you're going to this actually would be technically a partial gesture sketch, where or I mean a partial kind of contour sketch. What I'm going to do is sort of make it. Whoops, got to be on the screen, right? I'm making kind of a scribbly drawing. I'm doing a little one on the left there that's kind of popping up above the ice floe. And the trick here is to believe the penguin. Now your brain says, I want to draw that, the head, the beak, all these details. But what am I really seeing from this angle? I'm seeing a little thing with this. Pay attention to kind of the swoop of the neck here. And then what are the shapes? Think of the belly here. Think of the belly as a shape. It's sort of a very straight little thing. And so I've got a few little patches of dark. I have this little wedge of dark over on that penguin on this side. On this side, there's a little bar that comes down, and then around the back, I'm going to come down, and then in here somewhere, I'm going to turn back down in this direction. And then for my little head, I just want to don't draw the penguin in my head. I want to draw sort of what is the penguin that I'm seeing. I've got a side of the head that comes up steeply. It comes up to a tallest point here, back down, and then in. And what about under that head? So I'm just trying I'm trying to believe the shape that I'm seeing, and sort of getting like, where are these little weird inflection points? That's going to give me sort of a sense of that penguin. So pick a penguin in there and just make a few little kind of scribbly drawings and then go back into those and see and see what you can do to uh, to to find those penguin edges. I'm going to make this a little bit larger so it's easier for you to see. And you can't see my screen right now, and that's okay. But just start with a few little penguin drawings, and we'll kind of get a little bit more into details that will help you in a moment. If you find yourself mostly looking down at your paper, stop and look back up at the penguin shape. All the answers are in the penguin. And so what we want to do is get our brain to regularly check back with the penguin. More lines. These are really cool critters. Now, I'm going to bounce back there. So I've got a couple little penguin sketches. But let's now start to think about this thing a little bit more structurally and just sort of notice some features. Actually, I'm going to back up for a moment to this penguin. Notice that one there with its head up and all its little friends around it with the heads down. Right? So penguins are shapeshifters, and a big thing that's going to shift shape is what it is doing, how it's holding its head up away from its body, or if it's got the head tucked down into the body. Now, if the head tucks down into the body, where does that go? Let's take a look carefully at this penguin and think about its head being tucked back. And what can you notice? Take a close look at the change in the contour of it right under the throat and on the back of the head. What I'm going to do now is show my paper and this drawing at the same time and show how I might kind of go about thinking about that. So I usually I'm going to start with just sort of a place, whoops. Let's go for something a little bit darker. I'm going to start with kind of a placeholder oval for sort of the cylinder of this penguin's body. And I have a head. You'll have a tendency very often to make the head bigger than it actually is, because we human beings are really interested in heads. We often draw our heads way too big. So I'm putting in just sort of a little placeholder ball for that. And then I'll put in a little line saying my penguin is looking in this direction. Where down here is that wing coming out? It's coming out about here. Right? Notice if the wing comes out higher or lower than you think it ought to. Right? I've got a little foot leg area that I'm seeing on the bottom here. And a little penguin bit of tail. Now what I'm going to do is I'm going to carve into this, looking at what are called negative spaces. These are angles around the edges of the penguin. So look at this line here on the back of the head. I have a line that comes down and then it turns. There's a corner right there. I want to get that corner in my contour line. Sort of a smooth, rounded head, a little bit of a curve underneath the throat. On the front of this penguin, there's a bump here. See that bump? That's because the head is tilted, the head is tucked down. This bump here would go away if that penguin stretched its head out. So from there, the contour comes up, a little bit of a rounded penguin tummy. Let's go for the wing. The wing, you're going to come out straight, and then towards the tip, turn it down. On the back side, it's more of a curve, and it tucks into the penguin in here. But on the top edge, it's really coming out straight, and then somewhere in here, it starts this curve down. There's a tendency to draw it like a big hook, but it's going to actually come out straight with that inflection point kind of coming out down there. On the back, we have a little bit of tail visible. And then look at how thin the black part is. When something is mostly black, think of the black part as its own little shape. So what is the shape of the black that comes down here, that little armpit mark? I like thinking that's cool that those are something that is individual to each penguin. You're then, the markings kind of work up along the edge. And as you bring the head darkness in, avoid doing this. If here is my here's my penguin head drawn a little bit larger. Actually, we'll zoom down on that so that you can see it a little bit more. So let's avoid doing a little bit of a beak here. What I don't want to do is have this line come in like that. It is really tempting to take this and draw that line straight to the edge. But notice on that edge, there's a little bit of it comes down and it hooks up. There's a little bit of a whoop, a little bit of a hook there. The bottom of this penguin head, right? That sort of lowest point in that, this chest is turned slightly towards you. So you see that little loop there. If you get that in, it's going to give your penguin a lot more dimension. If it goes straight out to the edge there, your penguin's going to flatten out a lot more. So I'm going to try to avoid that. For drawing this line down the side here between the dark and the light, notice how tempting it would be just to draw. Then I've got a line that comes down here. But what you want to do is to look for any slight inflections in that line. And each place that that line that you're looking at turns direction, you want your pencil to turn. So if it starts coming down straight, and then it comes over this direction a little bit, and then back this direction, I want to try to capture each one of these places where the line changes direction, says something about the contour of this penguin. And if I can catch that, I'm going to be happy. Then I've got my little penguin leg coming down here, little thigh with my foot flat on the ground here. I'm seeing part of the other leg on the other side. So we've got a little from the front, you've got a little bit of penguin belly that comes down with little penguin legs on either side. So I'm seeing part of this, I'll paint it red here, belly coming down between those legs, visible through there. So what I want to emphasize is this idea of looking for these micro changes in angle. Let's try a different penguin. Aww. All right. These guys are just really, really cool. So what do we want to notice here? I want to sort of get us to notice that some subtle changes in angle are going to make a big difference. So let's look at the just the belly of this. Look sort of on the left-hand side, you see that belly come down, and then when you see where the leg is, there's a little bit of a bump that comes out. Notice there's a little shadow on the other side. Huh, there's something structural there that I want to capture. Let's look at the low point in that head. Notice that we're seeing a little bit more of the tummy view here, so that that low point under the chin, it's not at the edge, but it's in a little bit. Also, this penguin is holding its head at a 3/4 view angle. So we'll give you a few thoughts on how to play with that. So what I'm going to do to start is what I'm going to do to start is make myself a little, oh, that's pretty pale. Let's go a little bit darker. If you've got some colored pencils, try to find yourself a light colored pencil and kind of block it in with that. And then we'll draw more heavily along over that with another color, with a darker color in just a moment. So I have a head. We have a tendency to want to do this. We want to have a tendency to put the head up here, right above the body like a bowling pin. But this one's little head is off to the side. It's looking down in this direction. So I'm giving myself a head ball. I'm giving myself a body cylinder. And let's see where those wings are coming out. I'm going to draw that across the body so that my wings come out parallel with each other. I don't want one wing high and one wing low. And I think I need those higher. There I go. At the start of a drawing, I'm able to change the positions and places of lots of things. I can move my wings up or down, and I'm not really committed to much at the start. So moving my wings is pretty easy. Another thing that I think is useful on these is to think of where the middle of the penguin is. If this penguin were in its penguin suit and it had a little zipper up the front, where would the penguin's zipper go? If I can visualize that line of the penguin's zipper, that's going to help me be able to kind of keep track of where I am with this cool little bird. Now let's think about drawing in some of the negative space angles. I'm going to start up there by the head. I'm going to draw a little head diagram down here. Remember the zipper? Whoops, there we go. So this is my penguin head. The middle of my penguin head would come up through the middle of this ball. Imagine that zipper going all the way around. And I'm seeing a little bit on the side of this, the sort of a contour where its uh, its eye is going to tuck in on one side. So the head comes up, over, and then down. So I want to get this little notch in there. I want to think of this beak here attaching into the center line of this, so that the edge of this penguin is, the beak is going to come in here and the head is going to wrap around the far side of that. That's going to just turn that head a little bit towards me. If I draw it like this, so that here's my head and the beak is right at the edge of that, instead of, see how this is tucked into the head a little bit. If I put it right at the side, that's going to flatten that drawing out. So now let's come back up to this penguin here, and we'll try to do some of this. So if I have a little penguin beak that is happening in here, my head is going to tuck around the side of that. It comes up at an angle. There's a corner. Every time you see a corner, look for those. And this allows you to kind of carve your penguin. There's a little tiny glimpse of light underneath its beak here, where the other wing is coming in. That's going to help me place my other wing. I have a wing coming out here. Penguin belly coming down here. And now those legs, I tuck in a little bit on this side because I have a belly here that it's going to make a little contour on my penguin front. Our belly comes down between these. There's the leg coming down on the other side. From some views, we don't see the legs, right? We just have the little penguin shape coming down to the snow or the rock or the ice floe that it's rafting around on. I love the idea of these guys cruising around on those. And then we're coming straight down with a little bit of our tail sticking out here. On that far wing, give yourself permission to make it shorter. Right? So if there is a structure that comes out, turns down, and back up, and you look at that from a different, at a foreshortened angle, two things will happen. One is the whole thing will be shorter, but also this change in angle here will be much steeper. So expect, if you know that the penguin angle is something like that, when that wing is turned away from you, this angle here from where we start to go down becomes steeper. And the reason for that is, I'm just going to do this as a diagram. Think of the wing as these two portions here. There's a long part, and then there's the down part. And here I've made them the same size. This part here, the long part, is where underneath the skin, the bird has its elbow, and it has a wrist out here and a little penguin hand in here, right? It's a little penguin hand out in there. So what happens underneath when this gets foreshortened is this whole length is now shorter. So if this is this part here is this, and it's going to have to get from up here to down here in a shorter space. That means that this angle for the tip, the angle for the tip is much sharper. So expect that to, on the far side, to kind of turn around at a much more severe angle than we're used to. This little penguin's chin is going to come into the zipper line. So this is going to attach to the zipper.
Sorry, Jack, could you
Oops. Thank you. So I'm going to attach our chin to the zipper. Bring that wing up a little bit. I originally made this wing down a little bit too low, and I'm now can move it back up because I want to. You're not locked into any position that you put some portion of your little beastie. Just such cool critters. Right. We're going to do one final penguin sketch here. And I think do we want you? All right, so all these penguins are, oh, let's give you a choice. All right. So pick your penguin, and then let's really pay attention to, so again, if I were looking at this at these penguins, I would be looking for what is the shape of that black thing, right? Where does the middle of that go? That shows you where your penguin zipper is going to be. That's going to be really, really helpful. And also, I want to encourage you to consider, all right, check this out. If you are, let's say you do start with a little penguin drawing. You could do and you wanted to do several of these, you could make your next drawing over here. Or if you just look at the general spacing between the penguins, you just start your next drawing over here where it's going to actually bump into your other penguin. But just start your next drawing over there. And then you can tuck one penguin behind another. Easily said if you're looking at a photograph, right? Because you're just copying what they're doing there. But if you're actually out there in the field, these guys are waddling, right? And so your penguin is not holding still. And so what you do is you work on one drawing of penguin number one. You kind of get your penguin into shape, right? And then when you're ready to move on to the next penguin, just look at how close the penguins are. Start this next one over here. There's another penguin that is by them. You can start your next penguin back here. It's on a little ice floe. You can then have another penguin over here. And what you end up with is you get this little penguin huddle, right? That, what do they call that? The creche, when they have all those little babies together. So if I then just draw this next penguin with an adjacency to that first one that is you know, about the distances that I'm seeing these guys apart, I'm going to end up with this picture of penguins across the ice floe. All right, here's a little bit of snow here. So you can, if things are moving around, now let's say here comes another penguin waddling up, you can just drop them in adjacent to each other. And now these guys are, they're further up on a little chunk of snow. And there we go. Let's give this a try for this last little cluster of penguins. You pick your penguin and have fun with it. Might try overlapping some little penguin forms. Then I'll show you an interesting thing about penguin shadows. You may have already noticed it. So jealous of Anne getting to go spend some quality time with these beasties. And be sure to record some good armpit marks for us. Love the idea that you can tell individual penguins apart by their armpits. What might they be displaying?
I just put into the chat, I will never look at armpits the same way. It's just changed my life.
Ah. I'm going to bounce back in here for a second and show you something kind of interesting. And then we'll get back to that, those penguins again for a moment. So if you have a ball and it's floating out in space and sunlight is hitting on this surface, that's going to cast this far surface into shadow. So the closer you get to where the sunlight is, sunlight, shadow on the far side. Okay. That makes things look round. However, if that object is on a surface, and penguins are, I can't fly, then some sunlight hits back here and it bounces back to that object. So there's light reflecting off of this object. Think of when you're out in snow, you need sunglasses, otherwise you get snow blind because of all that light being reflected off the snow. Look at the reflected light on the bellies of these penguins. And what you'll see is that a bunch of them sort of down below have a zone that is lighter because there's so much reflected light. What we're going to want to tend to do is to shade these things like we shade objects that are on a less reflective surface. But if you're on snow, so you won't see this so much on the penguin that is waddling around on the rocks, right? But the minute they're on snow, there's all this reflected light on their penguin tummies, which means that up in here, if I am shading these guys, most people would say like, oh, you're just going to shade there and then it looks rounded. But this one's shadow is actually more in here like this. So it's got a side, the light's coming from behind them here. And we're getting some shadows across here. Maybe a little in here by that little leg bit. But there's also going to be a lot of reflected light that you're going to be seeing in these. And so that's an unusual thing about sort of sketching in really reflective conditions. So there's just a little bit of penguin shadows. Let's go back and just take a look at shadows on penguins here. Waddle, waddle. Notice where the light is reflecting. And before I close, give you a chance to play with that, I'll show you one more thing in just a moment. How can I make my penguin feel less flat, even more round, part with the shadow and part with this next trick? If there are penguins at a local zoo, I want to encourage people to take advantage of that. You can also find lots of great penguin pictures online, documentaries like The March of the Penguins. If you set yourself up watching penguins, try as an experiment, watching a documentary with a sketchbook on your lap and the goal of coming away with a bunch of little sketches by the time that documentary is over. You're watching something like March of the Penguins, by the time the last penguins are off, you've seen a lot of penguins going by. So if the penguin you're sketching moved, there will be a penguin in that pose a little bit later. All right, now let me show you kind of one last cool thing to make your penguin feel a little bit more volumetric. All right. I'm going to use this penguin here as my example. I want to think of this penguin
Jack,
as...
Jack, could you...
Whoopsie. That's right. Oh, that's right. I zoomed out. Zoomed in. All right. I want to use this little penguin here as my little example. And so because the penguin is not as tall as you are, right? Usually, that means you're looking down on the penguin, not in a pejorative way. No, we wouldn't do that, penguins. And I want to think of that like a can of beans. And when I'm looking down on the can of beans, I can see the top of the can of beans. And here is the side of the can of beans. You see this curve here of the cap and this curve here at the bottom of the can of beans? Things around this can of beans have that same curve. So this curve, it's because I'm looking at that can of beans from the side, it would be a straight little label there. But looking down on the can of beans, I'm seeing that as the purple curve. Now, imagine lines wrapping around the penguin. If there's a little kind of line of where I sort of see a little kind of edge of the feathers here, I might get, I might get some little contour lines that would be on these sorts of angles. So down here, what might I see if there are, actually, let's just throw in way too many on this. So a little line across here might come like this. Little line, if I see a little line of feathers here, I'm just going to see that kind of, it wants to do this. It wants to wrap around the penguin like this. See how this kind of scoots up here and then down across the front of the penguin and then up this way? Right, that's what our contour lines are wanting to do on our little penguin friend. So if this little penguin here has some whip little markings in its fur, I might see some suggest that there is roundness in the penguin. So let's look back at those penguins and see if you can see any little contour lines that you could wrap in there that would help give your penguin dimension. Look at that one on the breast of the one on the back left. Look on the sides, the flanks of the one top right. Right, so a few little marks like that just suggest that your penguin is rounder. And those are some tricks for playing with penguins. So what we're going to do now is, going back to my Zoom screen, I am going to bring Dennis back in and add you to the spotlight. So there's a little bit of penguin play there. And what we'd like to do is we would now like to send out to the audience here. Are there any questions that people have about penguins? You are live with, you know, you're probably looking at right now the current world's expert on knowing the behavior of Adélie penguins on sea ice, because as Dennis mentioned, there's so much that's not known, so let's there may be questions in the chat. Avea, if you do see any, you can share those with us. The other thing we can do is you can use the raise hand function to ask questions, and then we'll see that you've got a question for us. Also, if you can't figure, sometimes it's on Zoom, it's hard to figure out how to get the raise hand question, the raise hand function to work. In which case, if you feel comfortable turning on your screen, you can just manually put up your hand like this, and we'll see that. Let's first bring on Ann Chadwick, and then I see Chloe, and actually, yeah, here we go. So we're going to bring on Ann, then Chloe and Avea. Ann, thank you for being with us.
Great. Thank you so much. And great job, Dennis. That was a wonderful presentation. I learned a lot, and I'm part of the organization. So, and as I say, I will never look at penguin armpits the same way, and it'll help a lot with my sketching while I'm there live. And great tips. Can of beans, remember that one too. So my question is, in your research, are there some downsides to the Adélie penguins going farther from, where they need to come back to? Doesn't that take more energy then for them to get back? Do they ever go too far and say, that wasn't such a good idea? What happens there?
Yeah, that is true. There is sort of a balancing act that's going on for them. So our birds, our study species on Ross Island, they're one of the southernmost breeding colonies in Antarctica. You know how like the Ross Sea sort of dips down, so they're really far south. A lot of penguin colonies are further up north, and they don't have this sort of same long migration pattern that ours do. And I was talking about that Ross Shower that moves around, and what we did notice is that there's an association with the speed of the Ross Gyre for those birds that are going over to the right. So the faster that gyre is, the higher up those penguins end up going on their movement. And so, and the higher up they go, the further they are from their breeding colony. And so eventually at some point they have to go back. And when they're going back, we found that they're actually moving against that ice flow. So there's sort of this balancing act again that's happening there, that you can be taken up and be helped, but if you get too much help, you're ending up further north, and you might have to expend more energy on your way back down.
But they always come back to the same breeding colony, the same space. Is that right?
Yes.
Individuals. Yeah.
Each
Okay.
individual comes, it's amazing. They come back to the exact same little circle where they nested last year. So that
Whoa.
they can go, thousands of kilometers and come back right to the same spot every year.
So cool. All right, I'll let other people jump in now that I see.
That's cool. So I want to ask a couple follow-ups on Anne's question. So you're on the ice. You're in that fast current. If they stay on it long enough, would the gyre bring them back around, or does it spit those out into the main current? Or do they just melt by the time they get up there?
No, that was one of the hypotheses we had, is that like they would sort of just ride it, go north and then ride it back down. But throughout the season, throughout the winter season, the way that ice moves is sort of changing, and towards closer to when they have to come back down, the ice tends to be really be pushed off, kind of spinning off to the right, and so they can't really just ride that off, because they would be spun up out towards the Antarctic Peninsula, and so that's why when they're coming back down, they're kind of moving against it.
Excellent. That's really cool. Yeah, just think of like all the with your this is biology meets hydrology meets meets climate change meets penguins are cool. Let's bring in Chloe. It's really good to see you. You are now live. You are live with Dennis. Good to see you.
I had a question. Well, I had a couple, but how do they protect themselves from the wind? Because you made it sound like it was really windy.
Yes, it is windy, for sure. It's one of where we work is one of the windiest places in Antarctica, actually, and we can have windstorms that with winds blowing over 100 miles per hour. And for us, we stay inside when that happens, and the winds can go on for days, literally, and we have to just stay inside our little wooden hut for days. But the penguins are adapted to this. They huddle down and they can sit down on land, and they have that sort of torpedo shape for swimming. So I think that helps them probably, deflect some of this wind off of them, and they're able to just bunker in place. And we think that they might be doing this when they're out on the sea ice as well, but we're not sure. So one hypothesis is that when there's rough ice, that they might be attracted towards sort of this rough ice to protect themselves, but as sort of a windbreak.
Yeah.
But we really don't have the data to sort of, not yet at least, to sort of understand how they use ice in that way.
And no graduate students are volunteering to ride the sea ice out with a group of penguins to watch what they do when the wind is howling out there at 100 miles an hour.
No, not yet.
Not yet. Not yet. Do these penguins, I know like the emperors will like get together in a big huddle so that the wind is blowing towards them, and then the ones on the windward side get cold and they walk around to the back, and then they're protected from the wind, and now there's new ones, so that they kind of do this as the wind blows, they keep kind of walking around the outside edges and getting to the back of the group as kind of a pack heating system. Does this species do that same behavior?
Yeah, so that sort of grouping behavior that you've seen on the March of the Penguins, that's really cool behavior. And they're allowed to do that, or they can do that because they're sort of they're not stuck to these sort of nests that the Adelie penguins are. So that the Adelies are, this is my nest, and if you come close, I'm gonna bite you. And so they have to more deal with it on their own when they're breeding.
Oh, so if you're holding your egg on your feet, so your nest is wherever you go, you could then do that group behavior for keeping you warm. But if you're defending your little piece of turf, you can't.
Right. Yeah.
This is interesting. But we saw that creche of the babies. Do the babies in the wind get in big huddles and do that behavior?
Yes. Yeah. Once you're crushed, they're not as tied to their nest site, the babies, so they can go out and gather in these groups and huddle for warmth, for example, and especially when it's windy and cold.
Oh, that's cool. Chloe, did that answer your question? Great. Thank you very much. That was a really really useful question. Do you have any other questions for Dennis?
I was wondering how much they ate.
Well, it depends sort of like at what time of year it is. And there's periods of time during the season when, for example, they're replacing their feathers. And when they're doing that, they're out on the sea ice and they have what we call a catastrophic molt. That's just a term, but it basically means that they drop all of their feathers off and then regrow all of their feathers. And so when they're doing this, as you can imagine, if you're sitting out there and you don't have your feathers, you're kind of growing in the feathers, you're exposed, you can't swim really, you can't go into the cold water. So they can be in this sort of state where they're renewing their feathers for a couple of weeks and they're not eating anything during that time. But depending on like I said, the time of the year, there could be periods where they're really intensifying, like how much food they need, how much they're foraging. And you can see that with the data that we have with their dive profile, so how deep they're going. And we can actually see that change throughout the year. So like in 1 month, there's not much diving going on. And then another month comes in and you really start to see the movement of them going down and into the water and catching these krill and fish.
And do you think that is because are the fish being constant at their depth? Is it that sometimes the fish are closer to the surface so they don't have to do big dives, and sometimes they're deeper, or is it that the fish are always deeper so that when you want to get those fish, you really have to go deeper? Or is that another thing that we don't know yet?
No, it's another thing that changes, at least for the penguins that we study. Their depth can change throughout the season, and there's evidence that we've seen that early on in the season versus later in the season, once they sort of go out there and they're bringing back food for their chicks, and they're eating a lot of krill. Once those krill start to sort of like dissipate a little bit, there's fewer of them, and they have to go down deeper because that's where the fish are. And those fish, they're going down deeper, but they have more energy. So it makes it worth the extra energy to go down deeper. So we actually see that the krill and the fish changing their depth, and the penguins are sort of adapting to that throughout the season.
What a cool system. That's really fun. Chloe, did that answer your questions?
Yes, it did.
Thank you so much
Chloe.
for asking your questions. How's the spare change game?
They're good, but I have some bad news.
Oh,
Penny
no.
did die.
Who did?
Penny, she's the smallest.
Yeah. Oh, I'm sorry to hear that. It
Mm,
was so much fun to spend some time with them. The others are okay?
yeah.
Nickel and dime. All right. So if you weren't with us earlier, Chloe's got some amazing little mice that are really, really, really sweet. And they joined us for one of our workshops on drawing mice. So good to check in with them. Happy New Year to you. All right. We're going to bring in another voice from the community. I don't know who it is, but your hand is up and it says iPad. And you can currently unmute if you want. And if you want to, you can turn on your screen, but I'm going to push the button again to allow you to unmute. Here I go.
It says that they're trying. Their message said that they're trying.
Oh, okay. Why don't I have hands off? And because sometimes, like if Avea hits unmute and I hit unmute, then we're muting and then we're kind of canceling each other up. So I'm going to take my hands off and see if that gets us through. Crossing our fingers. While iPad is trying to join, if it doesn't work to join us that way, perhaps you could type something into the chat and we can see it that way. But Avea, you had some questions or thoughts or ideas.
Oh yes, I was going to read them out from the chat.
Oh, great.
I saw that that Barbara earlier had been raising her hand, but you lowered that. I just wanted to make sure, Barbara, if you wanted to have a turn, that you had a turn. Uh-oh, I don't see where you just. There you are. Okay, there you are. Here, I'm going to let Barbara go first, and then I will go after you, Barbara.
Hi, Avea. Nice to see you, and Jack and Dennis. Thank you so much for your presentation. I would like to know about the chick bearing. You mentioned 1 or 2 chicks, Dennis. So do they only have 1 or 2 each year? And then
Yes.
how long do the young stay with the parents? And what's the kind of family chick development behavior like? I'll take my answer off the air. Thank you.
Okay.
Barbara, thank you so much. It's good to see you and Happy New Year.
Yeah, thanks for that question, Barbara. So let's see here. Yeah, they have the standard model is that a pair of penguins will come together and they will lay 2 eggs. So that's 99% of the time that's what's happening. And so they both parents are there taking care of the eggs, but initially early on they'll take turns switching. So during incubation, the eggs are laid, and then the female will go out back into the ocean and try to replenish her energy for a few days, and the male is sitting on the nest for a few days. And they'll sort of do that periodically in the early part of the season, switching off, allowing themselves to go get energy and then come back and incubate the eggs. And then once the eggs hatch, then it's sort of continuing this sort of switching process back and forth of male and female going off the nest and coming back and feeding the chicks. Over time, these chicks, over the amount of time of a few weeks, these chicks, you can imagine, are starting from this really small size, getting bigger. We call this like a lime or lemon size, and they get bigger and bigger. As they're getting bigger, you have these 2 very hungry birds that are getting bigger and hungrier. Eventually, they reach a point where just having one parent going out is not enough to satisfy those chicks. So when they reach a certain point where they're able to kind of waddle around on their own and join this crush, that's sort of part of the process that lets both parents then go out at the same time, get food, and then sort of both be coming back in, finding their chicks in that crush and feeding them. If that makes sense. And they'll do that until the chicks basically lose all that sort of downy feather they have and start to molt and etc.
I've got a follow-up to Barbara's question there. And Barbara, if you've got, just raise your hand. I can see if you have more questions that you wanted to follow up. Let's first bring Barbara back in, and then I will add Barbara, you are back.
Okay, so thanks for that, Dennis. So how long is the incubation period? And then how many days, months before they're able to waddle around and join a crush? And then the question is, at what point do the young become mature enough to kind of venture out on their own? Do they then separate from the parents? And do the parents come back together the following year, or do they just keep changing mates year by year? And what happens to the young?
Yeah, so the penguins are coming back from their migration in sort of late October. They're starting to make their way down, arriving at the colony late October, early November, and laying eggs at that point. We start to see that eggs start to hatch around mid-December or so. And then the fledging starts to happen more in earnest around late January. I'm trying to think of the other. So in terms of mating, and if they're together at the same time, it's complicated, just like anything else in ecology. So the one thing that is pretty constant is like that the adults are trying, I think, to find, they're coming back to the same nest location. So if they can find their same mate, it seems like they do try to do that, but things change out there. Birds are dying, birds are moving around. They have their own needs, so it's not a given that they're mating for life, but something that they attempt to do as well. And so that the chicks themselves, for us, come late January or so, they're and early February, that's when they're sort of have their first feathers out, and they're starting to sort of begin to venture out, become curious about what's in that ocean out there, and start to head out there. Now, I haven't been there for that period of time because it starts to get very cold. The days become a little shorter. You start to get the setting in of some nighttime as well. So we're out of there when this is happening. But we are putting trackers on young birds now and able to sort of get a better idea of what they're doing when they first go out. And chicks, when they go out into the ocean that first time, we don't see them for 3 or 4 years. And they're out there in the ocean for 3 or 4 years until they're ready to come back to the colony and start breeding.
4 years out in the ocean by themselves?
Well, yes, by themselves. I mean, with other penguins, but yes.
But then they will return to their original colony nesting site. Interesting. Wow.
Yeah. The majority of them do.
Do the parents teach them how to fish? I mean, like peregrine falcons, for example, the parents will teach their fledglings to fly and then teach them to hunt. Does that happen with the penguins, or do they have this sort of innate ability to forage for themselves?
Yeah, that's a good question. Yeah, in some penguin documentaries, there's one that was created by Disney that was filmed at our study colony. They sort of have this implied thing where like the parent is like taking its kids out and showing it how to swim, but I don't really know if that's true. It tells a good story, but have not really looked into that. But I would guess that just like a lot of wild creatures out there, that they've developed these things and that help them get started, and once they begin doing it, they can learn it on their own, learning by watching others, and communicating and that sort of thing. So
thank you.
Sure.
Those are Wonderful questions. Thank you so much for that. I've got a kind of follow up on that, thinking about these little puffballs kind of getting out on their own. I know for even like a big emperor penguin chick, the skua is a really dangerous beastie. They're a bird with kind of an axe face, and they'll kind of come in and they can eat what they want when they want. Um, so these are smaller. What is how do they survive skuaing?
Yeah, good question. Skuas are the main predator of chicks at our colony, and I sort of describe them as a gull on steroids. They're really beefy, chunky things.
Yeah, and
Very
anybody who's curious about this, like look up like bloody skua online, and you'll find like these things are just like
yes, exactly. Yeah.
Sorry.
And they're very smart too as well. So they'll so one thing that Adelies are able to do is that they nest in these large groups. So they nest in this sort of big amorphous conglomerate of penguins on land, and just having the sheer number helps with protection. So uh, penguins sort of seem a little like loopy and dopey on land, but they're actually really strong birds. So like I've gotten flipper bashed by them, and it hurts. It can leave a bruise for sure on your legs. And you can imagine, even though skuas are big, tough birds, they also don't want to get hurt.
Yeah.
So a few flipper bashes, you could break a wing and you're done. So
Wow.
they have to use their sort of cunning and trickery a little bit, to sneak in along the edges of these breeding colonies and try to like take eggs. They're always looking out for any bird that's perhaps not paying attention, for any bird that's not distracted, and they can come in at that moment and sort of grab an egg or grab a chick. Yeah.
That's cool. And then a parallel question. Do leopard seals migrate with the ice flows to take advantage of the snacks that are going out to sea?
Oh, yeah, that's a good idea. I don't know if what they're just how leopard seals are moving around during the winter. Um, they're the main predator of adult penguins at the edge of the colony during the winter. I'm sorry, during the breeding season when we're there, and we've seen them attacking penguins. But once winter comes in, yeah, I don't know.
Interesting. So are we able to get through to iPad yet?
iPad put their questions in the chat.
Oh, thank you, iPad.
And so there are 3 questions. And I was almost going to make a Monty Python joke there about 5, but okay. Okay, 3 questions.
3 main questions.
Yes. So first question is, do penguins recognize each other by their armpit marks? Our second question is, are the armpit marks the same or different on each side of the penguin? And then also, is there an evolutionary reason for said armpit marks, like a mating thing, or is it just a cool quirk of the penguins? Those are awesome questions. Thank you, iPad.
Yes, lots of good questions. So, okay, the first one about how do they recognize each other? That's a good question. And we have ideas, but we don't really know for sure. But one way that penguins seems that they recognize each other is through their voice. So they'd have this call, or sort of kind of like a song that they'll do to each other when they first meet, when they're pair bonding is what we call it. They're trying to get to know each other, and they'll do a lot of calling to each other and moving around, doing a display. So we think that voice, they can recognize each other with that voice. And they'll also do calls when they're on their nests with eggs. And, for songbirds, at least, there's evidence that they're doing this singing and calling, and the chicks can sort of pick that up through the eggshell. So we think that the voice is really important. Whenever they come back from foraging, they'll do the call, and that's sort of a way that they're saying, "Are you really who I think you are?" The whole thing with armpits, the armpit colorations, is for now it's sort of an idea that we all kind of toy around with, but we don't really know if these armpit markings are sort of an identifier for them at all. We do see variation in those armpit markings. You know, sometimes we're out there going like, "Ooh, check out that, you know, penguin. Look at those sexy like armpits," like, and they're kind of showing it off. But for now, we don't really know. Yes, exactly. But it's an interesting idea, and if anyone wants to sort of follow that path someday and learn, you know, try to test it out.
That's cool. Can you imitate the call for us? Put you on the spot here. So I want to hear your best, your best Adelaide penguin call.
Well, it's impossible really because it's such a complex call. It's got multiple layers, but it's if you're forcing me.
Oh, we are. Wait,
Yeah.
actually, I'm going to just take a look at the group. What do you think, folks? Yes? Yes, we are. We're forcing you.
Let's see. I've never done it before, but it's sort of, it's going to be horrible, but it's kind of like a stuttering, like something like that. But it's got lots of layers to it, and you know, you can hear some deeper guttural sounds as well, and some higher pitched ones. So.
Nice. That was good. Yeah, Chloe's giving you the big claps. Thank you. Let's join the. I know we have to let you go in the foreseeable future. But let's join the Mad Botanist again, who's got a few questions off of the chat, and then we also want to bring back in Ann Chadwick. So Avea, wasn't this fun? I mean, just first of all, can I say this was, you knocked it out of the park. That presentation was brilliant, right? Really, really, really interesting. And we're really excited that you're doing this. Like these penguins are so cool, and the research that you and Point Blue are doing, this is just amazing stuff. So I'm really, really, really happy that we got this time to play with you. We're going to bop a few more questions at you, then we're going to join Ann Chadwick, and then we are going to wrap for the day, and we'll let you get about your business. But we're really grateful for you coming and spending this time with us.
Thank you.
The chat is full of people thanking you and saying how much fun that they've been having learning about the penguins and drawing them and just falling more in love with their adorableness. So thank you. And here are a few of the questions that we have. Bethany was asking, do penguins have bristle feathers around their beaks? And if so, are they used to catch prey in, I guess, murkier water, like nightjars?
You know, not any specialized feathers that are used for capturing. They do have very specialized tongues. So the tongues have sort of bristles that are pointing back, so that when they do capture something, it sort of helps keep it inside their mouths. And their beaks also seem to be very sensitive. So the videos that I said we've been putting cameras on penguins and seeing them forage, we can see them going into the water and capturing single, like, individual krill. So like one little tiny krill, it's like a mini shrimp, and they just go up and snap that guy up, and then go on to the next one and snap it up. So their bills are highly sensitive, and their vision is really good to help them do that.
Do you think that when they're down in the dark? Are they going? Do they dive deep enough to be in the midnight zone or anything like that? So, and when they're down there, what sense do you think that they are using to get those little fish and krill?
Yeah, we do see them dive down, but they are limited by light, so they need light to help them hunt. So they could be doing things as well, like diving down and then looking up, and so they can see through the light, so shadows basically, or the sort of the shape of things against the backdrop of the light that might help them as well. But overall, this is part of the reason why our penguins move north, because the light is leaving sort of that area from the south, and they're sort of trying to get north so they can stay within the light.
Oh, of course. North with the light. That's cool.
Indeed. Do we have time for a few more questions?
Yep.
Okay, because I want to be respectful of your time, Dennis, and we've got so many good questions here. There was another question.
Let's take two more.
More. Okay. There was a question here. I'm trying to scroll up to find it from Timothy Hutchinson, who wants to know, how is sea ice disruption affecting predation from orcas and seals?
So in terms of potentially making penguins, interact differently with the sea ice, or have something like that, that's an interesting idea. So what this makes me think about is when they're vulnerable, when they're molting their feathers. So there's that time I told you where they have this catastrophic molt, and during that time they're out in the ocean. So they're actually out on sea ice. And a paper that my colleagues published recently was looking at that specifically and seeing how the ice during that important molt period is changing. And there was a couple years recently where that sea ice was extremely low, right? So this is something that penguins depend on, their sea ice obligates. So this could be one way that the changes in sea ice are making them more vulnerable, not only as fewer places to go to molt on, but perhaps making them a little bit more crowded because there's less ice, and then that could make them more vulnerable to leopard seals, attacking them if one comes up on the ice and doesn't fit and has to kind of stumble back in the water. That sort of interaction that you can imagine. Now, you asked about orcas and killer whales. The killer whales that we have within the Ross Sea, they're known as fish eaters. So they don't really attack penguins. We have seen it a couple of times where they're sort of chasing penguins around, but that's a little bit less of a thing they do. They mostly eat fish.
And so this catastrophic molt, is that during the winter? When they're out on the sea ice?
Yeah, it's right after the breeding season. So March and April. So they'll breed and then they'll go out into the ocean. So it's like sort of the beginning of the winter sort of transition period.
That seems like a really lousy time to have no feathers.
Yes, but so this period where they're on land, I think might be a lot going on for them. They're coming on land, they're feeding their chicks, they're getting all muddy, and so that probably has a lot of impact on the quality of their feathers. So once they're done with that intense period of breeding, it's sort of like, okay, we have to spend the next 8 months out at sea. Let's change up our feathers and have a fresh coat on.
Then we've got time for one question, then we'll bring Anne back into the room.
And this one, I guess,
you mentioned that Ray Bonto had a question.
Or he'd been raising his hand earlier on. We wanted to make sure we didn't miss you. Ray Bonto, did you have a question or want to share?
I'm not really sure if this is a relevant question, but I was wondering, what is the likelihood that a chick will survive up till adulthood?
Very relevant.
Yes. In general, it's very low. So we don't see very many, like I don't know the exact percentage off the top of my head, but we put these bands on the chicks at the colony, when they're of adequate size and big enough to deal with a band on their arm. And so we can track if and when they come back, and the large majority of them, we never see them again. So it's a tough life for them, for sure. And especially because they have to go out there on their own for 3 or 4 years. And I imagine over time, they're not making it back.
Yeah, that's a very good question. Thinking about, it'll also be interesting to look like, over the course of the life of the penguins, like what are, how does mortality, I would imagine at the start, lots of mortality, then in the middle, you kind of are getting things figured out, and then towards the end, you're kind of being an older penguin. And great question, Raybanto. Did you have any other questions for Dennis while you're here?
No. Thank you.
Great.
Yeah,
Thank you.
that idea of mortality and learning is really interesting to a lot of my coworkers as well. And they've been looking at things like how good is a penguin at foraging over time, and do they keep getting better? Do they, is there a drop off? And what we're seeing, it seems like a basic question. It's like, of course, as you get older, you're going to get better, but like knowing exactly how that changes over time, we've seen that birds do get better at foraging over time, like more efficient, and then they're sort of reach this peak, and then they kind of drop off at the end when they reach a certain age.
Thank you.
Thank you. I'd like to, we'd like to bring Ann Chadwick back into the conversation. I'm so grateful to both of you and the team at Point Blue. Avea, could I bring you into the screen as well? All right. For your insights into this, but more importantly, this is fascinating for me, but this is also essential for policymakers. And people are trying to figure out, like, where should we have a marine protected area? This is really practical information that we need to make good conservation decisions. The floor is yours for any other thoughts you'd like to leave the community with.
Well, thank you so much, Jack, for having us. And Dennis, great job. And Lishka, thank you for supporting us behind the scenes and for all that you do in communications. And Avea, always there, just making things happen. Always appreciate that. So, yeah, this has been just terrific. And that policy piece is so important. And that's one thing I'm trying to do as chair of the board. We actually formed a whole separate policy committee to try to make sure that our science, we're really good at scientists talking to other scientists, and that's really important. And our collaboration is a big part of what we do. And we also want to see our science get used in making smart decisions about marine protected areas or any number of environmental policies, or just how we are on the earth. So we're really trying to up our game on policy and communications. And part of that is art and science coming together to be better at telling our story and telling the importance of what we're doing. And I'm so pleased to see your work, Dennis. I don't think I'd ever seen what you can do before, and I just encourage you to keep doing that. And you're already part of our art and science committee, and just keep learning and sharing, and it's so terrific.
Penguin
And
Dreams was brilliant.
yeah, love it. And now I know what a geospatial ecologist does. That's pretty cool. And I must say that Point Blue, so we're a nonprofit, and that means that we're supported largely by donations from individuals like you, from philanthropists, from foundations. We get government grants as well. I believe the National Science Federation is funding a lot of our work in Antarctica.
Yeah, NSF. Yep.
NSF, yeah. So, but it's really important that we have a wide base of, different donors. And so if you're interested in supporting us, Lishka is popping into the chat some of the ways that you can explore how to get more involved with us. And it might be a financial contribution. There are also some volunteer opportunities, and just spreading the word about us. Or if you can help with advocacy or help us find grants, or if you're good at governance and you want to talk to me about, roles on policy committees or boards or whatever it is, I'm all ears. And we really just love having a large involved community to spread the effectiveness of what we are doing. And you can see how important it is, and what fantastic people we have. If you've been on any of our other sessions with Jack, you've seen some other brilliant scientists as well. And it lifts me up. It gives me hope, keeps me engaged, keeps me optimistic in some pretty tough, circumstances that we're looking at. So stay involved, get involved, and be part of the Point Blue community, as well as this wonderful and wonderful Nature Journal community. So thank you so much, Jack.
And thank you again, and Dennis, Avea, and everybody out there in the community. This is, I think it's really important for us to get informed, to get inspired, and to collectively take action to make our stay on this planet be for the better. And the work that you folks are deliberately doing to do that is so deeply important. Also, I know that a number of people often make a donation to help support me in my work as a part of these. I greatly appreciate that. But this week, I would like encourage anybody who might consider making a donation to me to instead to make it to Point Blue. And your donation will go to support to support Dennis and the penguins. This is important, and we really do make a difference. Vea.
Before we close, I wanted to ask, for folks who might have more questions for Dennis, is there a good way that they can get in touch with you? Because I see a lot more excitement in the chat, and I think people might want to reach out, if that'd be okay with you.
Yeah, I'd be happy to answer questions. You can through my email. So.
Or maybe should we send that to a Point Blue one to collect for you, or would you like people to email you directly?
It's either going to be me or Lishka. Someone's going to have to be collecting the questions. So you can email me. I don't mind, or if you want to,
right.
And I can send you out to to try to answer.
How should people get a hold of you? What's your email?
I'll type it up here.
Thank you. Oh, and Chloe is saying, "Oh, my penguin, that was good."
I absolutely agree, and so does Greg.
And I also wanted to say thank you also to John Muir Laws and Ivea. Also, like, this is really inspirational, and also to everyone here. It's really great to see so many people come in and be interested in nature and in journaling and exploring, and so it was inspirational to me too as well. So thank you.
Well, Dear friends, until we meet again, let's stay engaged, stay curious, be kind, and let's make a difference together. We are making a difference together. And thank you all so much. We'll see you soon.